I'm going to explain about infrared spectroscopy. Infrared spectroscopy measures the absorption and emission of infrared radiation by molecules. It provides variable data about molecular structures and chemical compositions. It works by passing infrared light through a sample and measuring how the molecules in the sample absorb or emit this light. The instrument used is called an infrared spectrometer. It detects the light intensity at different wavelengths. Each type of molecule absorbs infrared radiation at specific wavelengths, creating a unique pattern known as infrared spectrum. By comparing the spectrum of an unknown sample to a known spectra in databases, scientists can determine its chemical bonds, functional groups, and overall molecular structure. This information is essential for various applications including drug development, environmental monitoring, and forensic analysis. Principle of IR spectroscopy. Infrared spectroscopy operates on the principle that molecules absorb and emit specific frequencies of infrared radiation corresponding to the vibrational motions of their chemical bonds. This technique depends on the interaction between infrared light and the chemical bonds within a sample to provide valuable information about its molecular structure and composition. The principle behind infrared spectroscopy is rooted in the quantum mechanical concept of molecular vibrations. Molecules consist of atoms held together by chemical bonds which can vibrate or stretch in response to energy input. When infrared light interacts with a molecule, it can cause these bonds to vibrate in different ways, depending on their strength and geometries. The infrared spectrum obtained from a sample represents a unique pattern of absorption and transmission of infrared radiation at different wavelengths. Each peak or band in the spectrum corresponds to a specific type of molecular vibration, such as stretching, bending, or twisting of chemical bonds. By analyzing these spectral features, scientists can identify the functional groups present in the sample and deduce its molecular structure. Regions of infrared spectrum and its applications. The infrared spectroscopy divides the infrared spectrum into three main regions: near infrared, mid infrared, and far infrared. Near infrared region ranges from about 700 nanometers to 2500 nanometers in wavelength. This region is closest to the visible light spectrum. It is often used for analyzing organic compounds. NIR spectroscopy is very useful in pharmaceuticals, agriculture, and food science for quality control, ingredient analysis, and process monitoring. It can quickly analyze samples without the need for extensive sample preparation. The mid-infrared region spans wavelength from approximately 2500 nanometers to 25,000 nanometers. MIR spectroscopy is most commonly used region in infrared spectroscopy. It is highly sensitive to the vibrations of chemical bonds in molecules, providing detailed information about the molecular structure and composition. MIR spectroscopy is widely employed in organic and inorganic chemistry, environmental science, materials science, and forensics. It is capable of identifying functional groups, detecting impurities, and characterizing unknown substances with high precision. The far infrared region extends from around 25,000 nanometers to 1 millimeter in wavelength. The FIR spectroscopy is less commonly used compared to NIR and MIR spectroscopy. It is used in solid-state physics, astronomy, and atmospheric science for studying lattice vibrations in crystals, atmospheric compositions, etc. So that's all about IR spectroscopy. Thank you.